Alright, this
you
is
guys laugh.
PreCal Chapter 6, the partner test that you took on Friday. This is the non-calculator portion that we're going to be starting with. So question number 1 wants you to find the 6 trigonometric ratios for theta. And you need to rationalize and simplify the ratios. So, in the picture, our theta is up here at the top. We're given the shorter side and the longer side. We need to find the hypotenuse in order to find the ratios. So to find the hypotenuse, we're going to use the Pythagorean theorem. We're going to have 4 squared plus 5 squared equals c squared. We'll just label this as c. So we're going to get 16 plus 25 equals c squared. You get 41 equals c squared. So you get that c equals the square root of 41. You can't really simplify the square root of 41, so we're just going to leave it like that. So c equals the square root of 41.
Yum.
So sine of theta, remember sine is opposite over hypotenuse. So opposite of theta is 5, and our hypotenuse is the square root of 41. So you get 5 over root 41, but you need to rationalize. So you get 5 root 41 over 41. Cosine is adjacent over hypotenuse, so our adjacent side is the 4 over root 41. Again, rationalizing, you get 4 root 41 over 41. Tangent is opposite over adjacent, so you get 5 over 4. Now these bottom ones, the inverses, are not in order, so it's not, cotangent is not the inverse of sine, so you need to make sure that you're reading which ones are actually being asked for. So cotangent is the inverse of tangent. So we're flip the ratio that we were given for tangent, so you get 4 over 5. Cosecant is the inverse of sine, so you'll flip your sine ratio, so you get root 41 over 5. And secant is the inverse of cosine, so you'll flip your cosine ratio, so you get root 41 over 4. Number 2 and number 3 are knowing your 30, 60, 90 triangle and your 45, 45, 90 triangle. You're asked to find the exact value of x for each problem and rationalize and simplify if you can. So in number 2, we're given a 30, 60, 90 triangle and we're given the hypotenuse. So if it helps you remember, draw your 30, 60, 90 triangle. So this will be our 30, this will be our 60. Now you know that the shorter side is 1, the hypotenuse is 2, and your longer leg is root 3 in your standard 30, 60, 90 triangle. So in our problem, we're given that the hypotenuse is 40. So we know that the shorter side is half of that 40, so our shorter side is going to be 20. So to find the longer side, we're seeing that everything is a multiple of 20. So our longer side is going to be 20 root 3. So x for number 2 is 20 root 3. Number 3 is the 45, 45, 90. So again, if we draw our triangle, we know that the sides, the legs of our 45, 45, 90 triangle are both 1, and our hypotenuse is root 2. So in problem 3, we're given the hypotenuse is 14. So to find the legs, we're going to have 14 divided by root 2. And you need to rationalize that. So you get 14 root 2 over 2. And then you can simplify that as 7 root 2. So your x for number 3 is 7 root 2. Four through 6 are asking you to find the angle. So you're looking for theta. You're going to use the exact values of the trig ratios for the special triangles to find an acute angle theta in degrees. So we're going to use these two triangles to solve these three problems. So we're given that sine theta equals root 3 over 2. So if we're thinking about sine, we know that sine is opposite over hypotenuse. So we know that our opposite side is going to be root 3 and our hypotenuse is going to be 2. So if our hypotenuse is 2, we know that we're looking at the 30, 60, 90 triangle because our hypotenuse is 2. And then we need to find where our opposite side is root 3. So root 3 is opposite the 60 degrees. So this is a 60-degree angle. Theta is 60 degrees for 4. Number 5, cosine of theta equals 1/2. So cosine we know is adjacent over hypotenuse. So again, we're in the 30, 60, 90 triangle because our hypotenuse is 2. And now we need to see where our adjacent side is 1. So our adjacent side would be right here as 1. So again, it's a 60-degree angle. Number 6, we have cotangent of theta equals root 3. Cotangent is the inverse of tangent. And tangent was opposite over adjacent. So we know that cotangent is adjacent over opposite. So we can put that over a 1 and it's still root 3. So again, we know that we're in the 30, 60, 90 triangle because we have a root 3. And root 3 is our adjacent side. 1 will be our opposite side, so we're looking at a 30-degree angle. Number 7 says find side B in the figure below if sine of A equals 4 over 9 and A equals 8. And it gives the hint to draw another triangle. This is looking at similar triangles. So given this triangle, we know that sine of A equals 4 over 9. So our angle A is here. Sine is opposite over hypotenuse. So we know our opposite is 4 and our hypotenuse is 9. And then we're given that side A equals 8. So we need to draw another triangle. And labeling it the same as the other one. Remember that the side of a triangle, so side A would be opposite angle A. So this is A. Side B is opposite angle B. And side C is opposite angle C. So we're told that A equals 8. So in this triangle, our side A equals 8, and we need to find B. So if we look at our previous triangle, our A was 4, and our B was 9. So our A was 4, but now it's 8. So our A has doubled, so our B is also going to double. So our previous B was a 9. If we double it, now it's 18. So side B that we're trying to find equals 18.
Is the side
All right, now the back. It asks to find the exact values So the exact values are when you're finding like root 3 over 2 or 1/2. We don't want decimal answers here, and you don't have a calculator anyway, so you can't find the decimal answers. So, we want to find sine of 3 pi over 4. So first we have to find where 3 pi over 4 is. So if we look at our coordinate plane, we know that we have 0 and 180 degrees is pi. So if we cut that in half, we know that this is pi over 2. And we know that this comes back to 2 pi. So if we cut that in half, we have 3 pi over 2. So we're looking for, if we rewrite this, we're looking for 3/4 pi. So we're going to be up in this top portion because pi is right here. So we go 0 to pi. And we're looking for 3/4 of it. So if we split this in half, each 90 degrees in half, we've broken up the top into 4s. And we want to go 3/4. So we go 1, 2, 3. So that's 3/4 to pi. And we cut our 90 degrees in half, so these are all 45-degree angles. So using our reference angle, we know that this is a 45. So going off of our 45, you know that the legs are 1s, and the hypotenuse is root 2. Now this should be a -1 because our x's are negative in the second quadrant. So we need to find sine of this 45-degree reference angle. So sine is opposite over hypotenuse. So you're going to get 1 over root 2. And then you need to rationalize. So you're going to get root 2 over 2. Cosine of pi over 2. So again, we have our coordinate plane. We know we have 0, we have pi, and we know that at 90 degrees we have pi over 2. So this is where you have to use the unit circle, and we know that our point at pi over 2 is 0, 1, because the unit circle is the circle of radius 1, so anytime that it hits any of the axes, you're going to have a point similar to that. So we have 0, 1 for our point at pi over 2. So this is also when you need to remember how we redefine cosine when using the unit circle. And that cosine was equal to x over r. So we know, given this point, our x value is 0. And our radius of the unit circle is always 1. So 0 over 1 just equals 0. So cosine at pi over 2 is 0. For number 10, we're given tangent of 5 pi. So we need to find 5 pi. So again, we know that this is 0, this is pi, pi over 2, 3 pi over 2, and then this is also 2 pi when you've made a complete rotation. So if we're looking for 5 pi, we'll start at 0. That's 1 pi. Go around the rest of the way, you've gone 2 pi. Go around again, you've gone 3 pi. Again, you've gone 4 pi. And then one last time is 5 pi. So we need to find tangent of 5 pi. So again, using our point, we know that this point on the unit circle would be -1, 0. And we define tangent. Tangent equals y over x when we were using the unit circle. So using our point, our y is 0, our x is -1. So we have 0 over -1, which just equals 0. So tangent of 5 pi is 0. Is cosine of 17 pi over 6. This one we can rewrite as a complex fraction, or as a complex number. So we'll rewrite it. 6 goes into 17 twice. You have 5 6 left over, and it's still times pi. And then we can find our reference angle by subtracting 2 pi. So you'll end up with 5 pi over 6 is your reference angle. So again, we need to find where 5 pi over 6 is. So again, we have 0, pi over 2, and pi. So we want 5/6 of pi, so that's almost 2 pi, but we're going to divide these into 3s, each of our quadrants into 3s. So now we have 1, 2, 3, 4, 5, 6 sections, and we want to go 5/6 the way. So starting at 0, you go 1, 2, 3, 4, 5. So that's 5/6 of pi. And by breaking these up into sixths, we know that these are all 30-degree angles because you're dividing your 90s in 3 parts. So 90 divided by 3 gives you 30s. So your reference angle here is a 30-degree angle. And you know that in your 30, 60, 90 triangle, your short leg is 1, your longer leg is √3, and your hypotenuse is 2. And because we're in the second quadrant, your x value, or your √3, is negative. So we need to find cosine of this reference angle, so cosine of this 30-degree angle. So that's adjacent over the hypotenuse. So your cosine is going to equal negative √3 over 2. For number 12, you need to find the sine, the cosine, and the tangent of theta, given the point 2, -9 is on the terminal side of your angle. So, you want to draw this point just so you can visualize it. So you have 2, -9 is down here. You're going to draw a line from the origin going to your point. And then you're going to want to draw a line going back up to the x-axis to complete your triangle. So you have your 90-degree angle there. And this is on the terminal side of theta, so we've rotated like this to get to that line. So this is the angle that we're interested in. This is the reference angle that we're using to find the sine, the cosine, and the tangent. So you know that this is 2, and this is -9, so you know 2 of your sides. So again, you need to find the third side, and that's using the Pythagorean theorem. So you're going to have 2 squared plus -9 squared equals c squared again. So you're gonna get 4 plus 81 equals c squared. So you get 85 equals c squared. So you get square root of 85 equals c. And again, that's as simplified as that radical can get. So now you need to write your sine of theta, cosine of theta, and your tangent of theta. And again, this is your theta up here, this angle. So sine of theta, opposite over hypotenuse, which was what we just found. So you have negative 9 over root 85. And then again, rationalizing, you get negative 9 root 85 over 85. Cosine is adjacent over hypotenuse, so that's 2 over root 85. And again, rationalizing, you get 2 root 85 over 85. And then we need to find the tangent of theta. Tangent is opposite over adjacent, so that's negative 9 over 2. So then moving into the calculator portion of the test. For number 1, you had to basically punch those into your calculator and get a decimal answer out. And in the directions it says, watch your calculator settings. So if you're given something in radians, you need to put it in your calculator using the radians setting. If it's given to you in degrees, you need to use degrees in your calculator. So A and B are radians. These are both in radians because there's no degree bubble. So those are both in radians, and then C and D are in degrees. So A, when you punch it into your calculator, you should get 0.782. For tangent of 32 in radians, you should get 0.661. Cosine of negative 20 degrees gives you 0.940. And cosecant of a 47-degree angle gives you 1.367. So please make sure you're using radians when you're asked for radians and degrees when you're asked for degrees. Number 2 wants you to solve the triangle given that you have B equals 18 and C equals 12. So again, labeling your triangle correctly, the side is opposite the angle. So this is side B because it's opposite angle B. This is side C because it's opposite angle C. And this is side A because it's opposite angle A. So we're given that B equals 12, or that B equals 18. So we know that our hypotenuse is 18, and then we're given that C equals 12. So we know our longer leg equals 12. So we need to find A, and then we need to find angle A and angle C. So finding side A is probably the easiest part. That's just using the Pythagorean theorem. So you're going to have A squared plus 12 squared equals 18 squared. So you get A squared plus 144 equals 324. So you get A squared equals 180. So A equals the square root of 180. And then you can simplify this as 6 square root of 5. Or you can put it in a decimal form. I'll accept either one. So we get that side A is 6 root 5. And we need to find angle A and angle C. So, to find angle A, given our original information, we know the adjacent side and the hypotenuse. So we can use cosine of A equals 12 over 18. And this is when you would use cosine to the -1 and punch in your fraction, and you'll get a decimal answer. You should get 41.8 degrees. So if you know that this angle is 41.8 and you're looking for C, you can take 90 minus 41.8 and you'll get 48.2 degrees. Number three wants to know what is 7/8 of a circle in degrees and in radian measure. And it wants you to simplify your answer. So, to find 7/8 of a circle in degrees, you're going to take your 7/8, and a complete circle is 360 degrees, so we're going to multiply by 360. And you're going to get 315 degrees. So 7/8 of a circle is 315 degrees. 7/8 in radian, you're going to take the 7/8 and you're going to multiply by 2 pi, because 2 pi is a complete circle in radians. And you'll get 7 pi over 4.
If you were to do 315 over 1 multiplied by pi over 180 here, it's 360.
You
which
can
is
do that
over-
too.
Okay. Would it be over 360? It has to be over the pi over, or is it pi over 180? 'Cause if you
No,
were to-
okay, so if you wanted to, so you already found your degrees
Yeah.
of the 7/8 of a circle, and you want to switch this degrees to radian, you would take 315 degrees, and that would be times pi over 180, because that was your conversion factor. And you would still get the 7 pi over 4. So either way, you can do it. Number 4 is asking which angle is not coterminal with -543 degrees. So coterminal angles, remember, was adding or subtracting 360 for degrees. So if we take -543 and added 360 degrees, we would get -183. So